Hi everyone. So today we'll be solving the question from Strivers edition, that is find the duplicate number. And this question is a very simple yet most asked question in different interview companies. But you might see that this question is simple, but there are a lot of at least 7 to 9 ways to do this question. I would say better, give at least 4 to 5 different approaches in the interview. That would definitely help you to crack that interview. So let's give a question. The question itself says that there is a duplicate number and you have to find it, right? As simple as that. And also it says that there is only one repeated number, that is one duplicate number, and you have to find that duplicate number in the nums from the nums array. Okay, so here you can see the only duplicate number is 2, and here also the duplicate number is only one, that is 3. So the first thing what comes to your mind, like you can just sort the nums array, right? And then we can just use a for loop and check. Suppose we sort this nums array here, okay? Just see. Suppose we just sort, see example 1. If we sort this array, that is 1, 3, 4, 2, 2. If we sort, what will come? This, right? 3, 4. So if we just say that nums I is equals to 1. See, at this index, this is second index, this is first index, this is second index, right? Both of the elements are same. If nums I plus 1, I is equals to nums I plus 1, then returns nums I plus 1 or nums I. Simple, this is the array. First we sorted, right? First we have done sorting, and after that we have used a for loop. So the time complexity will be big of n log n, and the space complexity is big of 1. Now we are, so if I show you the solution for the sorting one, so it will be something like this. See, I've sorted it, and then I've taken, this is just for that, then I've taken a for loop, and I'm checking whether nums I is equals to nums I plus 1 or not. If it is, then we can just return nums I or nums I plus 1, anything we can return. And the time complexity is big of n log n for this. I'll just write it once. Big of n log n. This is the time complexity, and the space complexity is big of 1. Okay, so this was one of the solution. Now we can also do this solution using set, or maps. That is also one of the way I'll show, but that will have a big space complexity. But do say that to the interviewer. We'll just have a set, we will just take a set or a map. See, I have simply taken, you can take a set here, okay? Just remove map with, remove map and just write, erase map and write set. So I have taken initialized a set or a map, and then I have taken all the elements there. Now I'm checking if I have written any, if this is present in the map, if nums or nums is present in the map. This is the second, means the frequency. First is the number. If I would be writing dot first here, then it would initialize the number. But for second, this int is the number itself, and this int for this frequency is more than one. Then just remove, dup is equals to mu dot first, the number, just return the number. Since we need the number, we don't need the frequency of the number. Of course it will always come to, but we need the number. So that's why I've written dup is equals to mu dot first, and I will finally return the duplicate. And this code actually have a time complexity of big of n, right, plus big of n, big of 2n basically. ठीक है, and a space complexity of big of n, right? So this is the way. And now let's move to the, this is one way. So for sorting, and then we have done the set thing. Also you can use two for loop. First for loop will run, like I will run from 0 to n minus 1. right? And the j will run from I plus 1 to whatever the things will be given, right? That is also one of the way you can solve this question. And now final the solution that is having that have a time complexity of big of n and the best most optimal solution for this, which have this time complexity of big of and of course the space complexity of big of 1 is the hare and tortoise method, okay? Or we also say Floyd's hare and tortoise method. Like, of course, we have bachpan se, like from childhood, we have been listening that story of a hare and tortoise where the hare loses when it's the fastest runner, but still he chooses to rest and he gets out of the league, right? And tortoise wins the league or the race. Similarly, here what we have, like we will have, I'll show my submission. So this is basically the solution for this, okay? So how, don't look in the solution for now, just let's look in the example how this works, like this Floyd's algo or hare and tortoise method, this one, uh Floyd's tortoise and hare algorithm. This is basically, how it works. This is a algorithm which, helps us to find cycle in an array or in a linked list. Again, this helps to detect a cycle, and also that cycle helps to find the duplicate. The main thing the Floyd algo do is that it just helps to find the cycle in an array or in a linked list or any other algorithm. But from using that cycle we can also find the duplicate number. Here is it, I'll tell you. So we, in the Floyd algo, we have a slow pointer which is our tortoise definitely, and we also have a first pointer, right, which is definitely our tortoise, right? Both of them are initialized at 0 0 respectively. Now if I just, this slow pointer will run by 1, always it will take always 1 step, and the first pointer will take 2 steps. So here if we see, both are at 1 1. So basically here how the things will work, at first slow will be here, okay, 1. And then what's the value of the, I'll just take this example, copy this and put it here. Let's write the index for each. 0, this is 1, this is 2, 3, 4. So this is the index for this, right? Now you know how this actually works. So both are present at 0 0, and the value of the, like this will move by that 1 move, and first pointer will always move by 2. That's why in the code we have taken slow num slow, and then this will like 2 steps. I'll go 2 steps. That's why I'm the fastest runner, like the first pointer. That's why we take it as says as first pointer, right? So now what will happen is that, like, see, 1 is here. So if I just write on the slow pointer, so this is at 1 0th index, right? So this is the array value at 0th index is 1. So now this 1 will go to the 1th index. It's not like it will go move 1 step ahead. No. If I would do that, then I could have just written, nums I plus 1. I have written, move the value. If this is having, if suppose this 0th index would have 2 instead of 1, then it would go to the 2th index. Okay. I won't move by, definitely I will move 2 steps, but by seeing the index value. So this is at 1. Now you will understand after you see the whole solution. So now this is 1. So it will come to the first index, which is having a value of 3. So now let's go. 3 is the value. So now we have to go to the third index, which is having a, if we come to the third index, this have a value of 2. So then it will come to 2. And then second, now we will move to the second index, which again have a value of 4. I hope you are getting the solution. right? And now 4, if we come here, the fourth index, these have a value of 2. See, again we are actually moving in a, and now this 2, if this 2 moves here, if it comes to the second index, it will again point to 4. You can see a circle forming here. See, 2 is pointing 4, again 2 is pointing 4. We don't have to, do this. It will do, but if we do this for both fast and slow pointer, this is forming a circle, na? 2 is pointing 4, again here 2 is pointing 4. Why will you take this? Just 4 to 2, and then this is forming a circle type, right? That is why we actually use Freud algo here to detect the cycle. And after that, what we will do is that we will take a while loop, okay, until slow and fast pointer meets, and at a point this both of them will meet, okay. When we move slow by 1 step and the fast pointer by 2 step, initially at a point both of them will meet and detect the cycle. After that we will run the while loop, and then the while loop will run till the time slow is not equals to fast, matlab they both are not in the same position. And then we will take the loop will, the condition to run the loop is this, like still slow is not equals to fast. Both have to be, if both are in the same index, we will stop running the loop. And then if slow, and then we have to put the slow as the in the starting, we will put the slow in the from starting index, okay, that is slow is equals to 0. And then again the while loop will run till slow is not equals to fast, but this time we will move both of these by one step, and until they meet, until it becomes slow is equals to fast, this condition comes true. Until this condition comes true, then we will stop, get out of the loop, or just return fast or slow, anything we can return. So that's the solution, the best solution for this particular question. And these have a time complexity of big of n and the space complexity of big of 1. I hope you understood the solution. And yeah, thank you so much for watching. Keep coding. Bye.